go ahead and have fun.
All right. Good afternoon, everyone, and thank you so much for coming to this session, University of Scouting in this pandemic. But I think that's a big change for us to, as a scout, to do our best and run everything, even pandemic or anything else. So I'm very happy to do it online, and I hope you enjoy it. So the very first thing that I have to talk about is this is for Cub Scouts. So I have another session for Boy Scouts. So I'm focusing just for Cubs and for packs basically. And I'm trying to give you a kind of idea. Most of you may know it, or you have experience with that. I'm trying to give you a little bit, about my experience and some other activities that we can have for our next generation people. So let me start with my name is Amin Ghafouripur, as you see it on the screen, and I'm teaching at Santa Clara University, and I was teaching at schools also. So I got experience to work with the younger kids basically, and have basically design some courses, engineering courses for them, and give them the opportunity to work with basically engineering stuff to have our next generation as entrepreneurs for our country. All right, so to start, I just want to start with this project that these little kids, I had it in 2016 and it went to the news. So my little kids with just popsicle stick, they built a building with Lego Mindstorm system. And they designed a building with basically building with just motors, and we put it on the shaking table and earthquake, and demonstrated the earthquake for them, and literally all the steps they did it. I was just an instructor, and because of shaking table and demonstration of earthquake, and design it with this, with popsicle, it went to the news. That was kind of new thing. So just want to share with you. It was in ASC news. This is another picture of that. Now, one important thing in Cub's activity is we have to believe that these kids, they can build something and they can enjoy. While they're enjoying, we want to teach them that you have to think, design, create, and ultimately be the next generation of entrepreneurs. That's the goal. And as we know that we are now the leader of the world in terms of engineering and science and other areas. I'm just talking about my area. So we have to continue to this. And the only way that we can do it, based on the recent research in the US, this is a paper, this is from ASEE, American Society of Engineering Educations. The only way is to promote more hands-on projects and especially start from elementary school, which is Cubs, to tell them that this country needs, science, engineering, and generally STEM for its future. So the teaching idea for the Cubs generally starts with this famous circle, as you know. Means we want to tell them that if I start from 6 o'clock, it's plan, create, redesign, ask, imagine. Or if I start from 3 o'clock, imagine, plan. So maybe the first step would be imagine, plan, then create, redesign, and ask, again back to imagine. So we want to help them to basically promote this kind of thinking and create an engineering mindset for them. And the best way for Cub and Cub, generally Boy Scout, is the hands-on project, as the mission is basically to teach these kids to do some hands-on projects in different ways. So I like to start with the NOVA Award program that basically, if you should have seen this website, and there are different awards requirements that for Cub Scouts, for Scouts, Boys Scouts, and venturing. So for Cub Scouts, the reason that I pull this here, because NOVA can give you a very good idea of the engineering activity in the packs. Basically, it's a good source for you to see what exactly can you do. For example, if I go to Cub Scout here, we have different genres here: science, technology, engineering, math. And in the area that today I'm talking about, it is mainly is engineering or technology, either or, but all of them, basically, we can classify them in science, STEM, basically, and you can use all of them for the for your pack. Now, in science, STEM, or science, technology, engineering, and mathematics, it's which is in line with the goals in public school and in basically in school districts mission. We want to promote the critical thinking, design, and creativity. So to do this, first of all, one thing that in your pack you can be the volunteer for that is to be the counselor and mentor for NOVA Award if you want to go for NOVA. What I'm saying here is not necessary to go for NOVA if you don't want to, but you can you can get yourself familiarized with that, and learn about the projects and run those projects in your pack. And then, of course, if you want to join, you can. But this is a good actually start. So they have some requirements for counselors, which NOVA counselors must be age 21 and older, register as NOVA counselor, and BSA, of course, as usual, youth protection training for all of us, and NOVA counselor training online. And mentors, age 21, and then subject matter expert in the STEM. And typically, I believe, especially in Silicon Valley, you can find parents, a lot of parents basically expert in this area. So I don't think, at least in our council here, we are short in science, technology, engineering, and mathematics. Then you can register yourself as Supernova Mentor and submit all these required information, youth protection training, and go to the training. So, and there are other also positions that you can apply for. It's NOVA chair position. This is a sample, but you can actually go for that if you like to. So this is important if you can start with the NOVA style activity in the pack. There are two sides and two benefits in that. One is, first of all, there is opportunity if you want to apply for the award. Second, it's the standard practice. So for example, if you see some basically for Wolf Cub Scout, Motorway, Pause Skills, Bear Cub Scout is Baloo the Builder, Bear Goes Fishing, and all others for Bibelos. So for example, for this one, we have even a guideline available on the website. So Cubs that can build, for example, the hiking stick, or practice activities with wood, or build this kind of things that you can see on the screen, homemade wooden candy dispenser, for example. So for Bear, we have this resource, and there are many others. You can just take a look at it. I just want to give you the clue that how can you move forward. Then for Wolf also, we have many other activities here. So like motorway, they can start working with small motors, a battery, a yo-yo. That typically we have it. I believe you should have most packs. They're running yo-yo. And talking about water, because they have to understand that water is precious. Clean water is the goal. Sometimes they think that, okay, I open the tap and drink water and that's it. This is water. But it's not really like that. So every single day when they wash their face or wash their hand, they have to understand this kid that this water comes from a lot of things, a process behind it that simply you open the tap and just get the water tap, drink it. So that's why it's important here. And these are the sample of activities that we can have. There are some options also in Nova if you like to work with that. Um, like for example, you can bring some old computers and break them. They love to break, things. So, or have a bicycle there, show them that, or on the old printer, take it there, break it and show how it works. And they ask them even to use a screwdriver to open it. Especially it works for wolf, bear and webelos, not really for lion, which is little kid, and even and tigers. These two are good for them. And again, this is another example of Nova Awards that in engineering that you can go and read basically on the website and familiarize yourself and use it for your pack. Some of these activities in different options, they're good for all, for example, ages. For example, working on this concept of simple machine, even you can have lions, but not like the way that we talk about, to give them a kind of opportunity. It should be a simple thing. They ask them to push something goes up, say that this is a seesaw, like like that, and talk up to give them the idea about simple machine. And then the tiger is also the same thing, but wolf and bears typically they can understand it. So I had class with bears. I mean, fourth graders to teach engineering, or third graders to teach engineering. I use just simple things like piece of paper, or to show them that how simple machines works without any complicated explanation. Honest with you, just to play with it and get used to it and understand that they're important. Um, but again, there are a good explanation on this website for the activity of each, like wolf, or each level of Cub Scout, like wolf, bear, or webelos. Now, this is about Nova, but I want to share some the results of some research and give you the notion that how important would be of teaching or working with these kids with hands-on project. How important is that for them? See, this is a part of the paper, research paper published in 2015 in JE Journal of Engineering Education, which is quite interesting results. There are some tables there. I grabbed just his table for high school students, but there are some other investigations about elementary and middle school students. But I just want to give you the idea. I copied this one. So if you compare only a student at school with a professional. So in this table, F is high school student, freshman, S is high school senior, E is you and I, experts in the area. So this is interesting if you see that for design process measures, problem scope and staging, so at high school and middle school or senior, junior, they are of course less than an expert, but problem definition, they can be like an expert. And I personally, when I was teaching at the school, I saw that some of these kids, they have some ideas, even like a PhD student, because idea, there is no limit and a limitation for the idea, but they don't know how to run that idea, and that's our job basically to help them understand. So and for example, for alternatives, so anything conceptual, they have the ability. And even in the lower level, for the cops, for elementary, maybe they don't have an idea, of course, because their mind are growing, everything is changing, but we can give them the idea that you can think, and there is no barrier for that. And that's why I shared this part of research with you, with this research with you, which is interesting. And we have to believe that if you want to have the next generation of entrepreneurs and designers and continue to be the leader of the world, we have to start from elementary school to give them the notion that you can and do your best. So that's why one of the things that I want to share with you is this annual event in Silicon Valley. And because we are here, actually, it's the best opportunity for all of us to go. This is the Silicon Valley International Invention Festival. Every year happens. However, honest with you, this year, 2020, we didn't have it because of this pandemic, as you know. But hopefully, next year we will have it in June. So I highly suggest you to take the kids to this event. They can meet inventors. Based on my experience, and I encourage school districts to come, Wolf, Bear, and Webelos, they are best candidates for this kind of events, because they will see ordinary people that they invent things, and they come to this event. So to give you a little brief on this event, this is under IFIA, International Federation of Inventor Association, and UIA, United Inventor Associations. So in this event, they invite, actually the inventors, they come to this from different countries in the world. Last year, 2019, we had about 100 countries. And there's a jury board. I'm the member, one of the member of the jury boards, and the advisor of the event. So we go there and give them the score and rate these inventions based on some criteria that we have. And every year, some of them, they will get gold medal, bronze, silver, you know, different medals or awards. That's the part of it. It's a kind of, you know, for them, for the inventors, it's typically, it's a kind of honor to get the, you know, something here. But for the kids, I want to focus on that. For the kids, they see really small or simple things as an invention. So it gives them a kind of idea that invention in these days is not necessary to be like Edison's invention or something, you know, revolutionary. So if they do something new, they can sell it in the market. So for the kids, the best thing to give them idea, I think, is to just meet these. Sometimes I saw some funny inventions that was really interesting for me and for other juries. So that's one thing that I wanted to share with you in the essence of this event. Any questions so far? All right, so then from this part, I want to share you with some different projects that you can run. This part is quite, it's not new to you. It's derby car competition. I believe all of you, you have it in your packs. And tiger, wolf, bear, bibelots. I'm not quite sure about lions, but they always do it. My son also, when he was the cop, he was there, and he got an award. So that's the typical derby. But what I want to focus in the essence of derby here, if you turn derby not just dad's project, so typically it's a dad project. So moms, don't get me wrong, I'm just moms and dad, or dad, by the way. But I mean, if we turn it to kind of learning material and even help them to understand some physical concepts, like for example for the location of mass and, you know, the form, friction, these kind of things that I believe most of you do, but at least to talk about the concept. For example, if you put the mass at the end of the car, it would work better because we will have more potential energy, or the physics behind this, or how can we reduce the friction. Basically, all of you, for derby car, always we have that graphite and those things to use it, but the kid should understand why. So you can turn it to those questions. Also, what I did personally for the pack and the past, and for my students at the school, I told them that, hey, look, this is the standard derby. Now, how can we change this? Let's do something else. We run this for a long time. So I have this video want to share with you here. So you can see, watch this video. Let me share it to you. This one. So uh, can you see the screen, right? John, can you see the screen? Yeah, okay. So yeah, so let's see what's the difference between this one and the other one. I didn't run this one. This is a cool guy. I saw it and I enjoyed with that. Take a look at this. So what he did, actually, he added a fan or a motor to actually increase the speed. So it's not the standard derby, of course, and it's not allowed for the standard derby, but it helps the student to think or rethink of something new. And we may be able to use it like a kind of idea, just, So I saw it with my students that they tried when I told them that use the standard derby, but then try to improve it with something else, not like derby car competition, but, do something. They came up with different ideas. I like that, basically with these things. So any questions, any comments on this? All right. Okay, so that's one item. The other cool thing that I personally I enjoy with that is spaghetti competition. Not to eat it, we're not going to eat those spaghetti or cook it, but to build a building and a structure with spaghetti. So for spaghetti competition, typically you need just 1 pound of spaghetti and hot glue gun. That's all you need. And then the students, the cops, they're supposed to build based on the guideline that I can share my guideline with you if you want to, but you can have any kind of guideline. My guideline is typically I give them, because of the age, I don't give them a kind of strict guideline. So typically I give them a guideline like just the size of the, this structure, the height of the structure, but always I'll give them the ability to basically to build anything that they want to with this, with the spaghetti. And then what we're gonna do, we'll put the load on that. We measure the weight of this, we put the load on that, and then basically the winner is typically the less ratio between, or the more ratio between load to weight. But you can change it always. Let's watch this video together to get an idea about it. This is one of the competitions that I had in the past. So let me go to spaghetti competition here. Watch this one. So the student built this one. For example, this is one of my teams, one of the teams. Measure the weight. 349 grams. All right. I believe we're going to start with these two, and then with these two, and then with these. And you can see those kids, they got excited basically. All right, next. 4,000, yes. 4,000 so far. And because I didn't have enough weight, typically I use, and this is the best thing, is just sand. Sand is the best way that you can add more weight to that. And yeah. They get excited if you allow them to pour, add those, the weight to that themselves. So. And then this one was actually was very strong. So if you see here, then I got the struggle. It didn't break with my anticipation. Then let's see what happened there. She didn't want to break it. So I had to add a little bit more weight to that. And it's to start breaking at this point. And my YouTube channel, it's on the. You can see more actually. I will share this with you. And then once it's break, we can measure the weight of the sand. So that's a kind of, cool thing that you can do maybe in the pack. It's not expensive, and actually it's one of the funny things that you can do. Any questions on this?
Yeah, I got a question. Was that a project where you let them build it at home first, and then bring it in, or did you spend an entire pack meeting trying to do that?
Partially at home, partially at pack, because they can't really finish it during that 1 hour basically thing. But for example, the very basic thing, the problem that they have, how to glue the joints together. So we did it in pack to show them how they glue it. Yeah. So and honest with you, especially for wolf and bear, I had less restriction. I just wanted to build them to build it, and then I had a score for aesthetic, not just the weight. And because they want to be winners, so we had to give them a kind of encouragement. So I had some scores for if they design it aesthetically very beautiful or something unusual, and from different perspectives. But this is the actual competition. So that's one thing. Another thing that I had it with little kids, not really with wolf here. I put wolf here, but this is my anticipation that they can run it. But bear for sure, and webelos for sure, they can run it. Is to use Tinkercad software. It's a free software on internet. If you search it, you can find it. And Tinkercad, simply they can design 3D objects for the 3D printer. So this object that you see, it's one of the things that my students they designed it. Just with this simple software, free software. You don't have to have 3D printer, because you can find anywhere that you send a file and print it for you. The parents can send it for a printer. So the only activity that they can have is just to, if the parents can maintain, for example, a kind of laptop or something, they bring it there, then or they can work in especially for a small group or a den, basically. Maybe 2 laptops is enough to just sit together, or even 1 laptop is enough to one den, or 2 groups in a den. They can design something with this, and then once they finish it under your supervision, if their parents want, they can send it to the print shop and print it and get this one. So it's very easy. Even and honest with you, again, what I've learned, 100% honest with you, I learned from my students. Not I just showed them the clue, and then I saw, wow, they got a lot of options there that I didn't personally work with those options. You know, these kids, they love to work with computer, and you know, that's the way that. So and the software designed like a game. So they start pooling the objects. It has simple objects like circle, cylinder, you know, cube, and they combine these cube, cylinder, and all these you know, all these shapes together. And you can see here, my students wrote smile here. The software has, you know, characters here. You can put it there, and another option to create a plate under it. And then I forgot, you know, she or he, but that this student basically merged a part of a sphere to part of the cylinder in the software, and create a kind of, you know, holder for her pen, you know, something like that. But for sure, Bear and Bibelows, they can do it. We can try with Wolf, by the way. All right, this is one another activity that you can have it. Any questions on this? All right. Another cool thing that you can run even cheaper than the spaghetti, that can be for lion, tiger, wolf, bear, and Bibelows, is paper bridge or paper bridge competition. Just glue, just paper, not more than that. So the way that it runs, typically they have to build a bridge. You can give them the idea of form for the bridge, and or they can. I typically, again, because of the age, I didn't give them any idea. I told them that you have to use paper and glue, and I just showed them how can they roll paper and get a better, you know, basically strength. For example, I showed them that if this is a paper, we don't have any strength if I put it like this. Then, but if I roll it, I just typically show it when I talk with the students. So if I roll it now, it has more capacity. So, and you can think whatever you want to build, but I just gave them a clue. So let's watch this video of one of these competitions. This is just paper. But they are not supposed to use tape around, tape it, you know, just tape around. They can use tape or any kind of glue just at the joints and connections. So I measured the weight. Typically I measure the weight and then put it on the supports. And you can find all these things at the school. So the school, typically they can help us with that. Because it's a little bit dangerous, make sure that the Scouts, they stay away of this, because it will fall typically. And watch your feet, by the way. So 6 kilograms for a simple piece of paper, or some pieces of paper. So at certain point, I had to add smaller weights. So it's very close to break. But this one, it was really good. So, and it got a little bit dent in one of the elements. So, yeah, so this is another, I would say this is the cheapest way that we can run kind of competition. Or if you don't want to have it turn into competition, just they can build it in your den, in the den. So any questions about this one? Okay, so the other thing that it's good just for Webelos, it's a little bit more advanced, is if you want to a little bit invest in the den or pack, basically pack, is to use popsicle sticks, which I believe you have it in your pack, in your pack, but you can purchase a Lego Mindstorm motors and sensors. So combination of, if you see this picture on the right, on top of this popsicle stick structure, there is a motor. There is a motor, you know, of Lego Mindstorm, and Lego Mindstorm designed for the age between third graders, basically, to around 6th grade, not more than that. So they can simply assemble that one, but I asked them not to use just Lego. On the other hand, I wanted them to build the structure or something with popsicle, and then they had to come up with the idea. For example, for this case, I asked them to start shaking the table, shaking this popsicle, or create vibration in this popsicle structure. So they built a shaking table. If you see the white, you know, plate under this structure with Lego, 100% Lego Mindstorm brain and motor. And then they programmed it. It's very simple programming with computer. And then we added even sensors to that to do something different. For example, when it starts shaking, the sensor, because there's a gyro sensor, the gyro sensor can do something else. So there are a lot of things that we can do, and I believe in most of the parents here, some of the parents in this area, you can find always parents in your pack that they're familiar with this, and because we're living in Silicon Valley, we take advantage of that. So this particular project, what I did, this is a little bit more advanced, but I asked them to build with popsicle stick, a building, put it on the shaking table, that they built it. And then I wanted them to counteract the vibration with sensors and another motor and mass. So they didn't know what they're doing in terms of physics and the physics behind it. So I gave them the instruction, but when they build it with the sensors, for example, the motion sensor or, you know, different sensors, they saw that when, for example, the structures move left, the mass moves right. So it's counteract, and actually this part I didn't intervene. I just they build it. So this is just good for Webelos. They can also use popsicle stick and motors to build anything that they want, like car or even boats or whatever. Isn't that why I'm saying that not to use 100% Lego pieces is just because when they work with popsicle stick and glue, they have they can think out of the box and they can build whatever they want to. Because once you give them the Lego pieces, they have to follow the pattern of Lego. But if you give them popsicle stick and the motor and sensor and the brain, the computer for that, the brain for that, then they can do more. We built even a boat, a car, a tank, you know, it depends on the case, or which went to the news. So this is one, and actually I wrote $500, but the price for one set of Lego Mindstorm is basically, it's $350. But if you just purchase brain and motors with $500, you can purchase a lot of brains and motors and sensors individually. Now, if you want to invest more, then you can purchase the whole kits for Lego or Vex IQ. I just put this slide to give you the vision for different grades here for robotic. So if you want to show robotic for the kids, for pack, Lego Storm is best, is the answer basically. However, for Vex IQ also, you may be able to use it, but it may give you a little bit headache if you don't want to, you know, involve a lot, just involve a lot. So I suggest you to go with Lego. So Lego Mindstorm is good for, again, some Wolf, but Bear, of course, and Webelos, and $350. And each kit can run about between 4 to 6 students, between 4 to 6. It's a group of 4 to 6 is enough for that, to build something with, so I believe one kit per den is enough. So if, and just to give you more information, Vex IQ is not related to this lecture, but it's for grade 6 to 8. For one kit is 750, and Vex VRC, which is 1200, grade 8 to 12. And Ftc Kit is, which is again grade 8 to 12. It's not again related to this, but just to give you a little bit more on the robotic. So, and with this robotic, you can encourage students to go to even competitions, FLL competition, First Lego League. So maybe your den can participate in one competition, but if they don't want to, they can build their Lego, the robot, like a car or something. I encourage them to basically build, for example, and use remote. There is a remote there, which is very easy. If they don't want to program it for a sensor, the easiest way to start is just using the remote. So with the remote, they built two basically robots. They were playing soccer. So one robot and two robots, they're pushing the balls, you know, to push them to the goal in each side, something like that. All right, so this is a picture. The right picture top, it's the students, it's elementary school students. So this is the robot that I told you that they built to play with balls in the field. And left picture top is the sets. However, this is actually, I ran it in the bigger institution. I had a lot of resources, but for the pack, you just need one set. Lower picture, it's the competition field. So if you want to get to the competition, then that's another option. Every year they have this competition, so you can go. So for competition, the robot's supposed to do some standard missions as described there per their mission. This is Vex IQ system. So you can see the difference. This is Lego system that you see the small picture, by the way, but this is the Vex IQ picture is good for middle school students. And with this robot, we won the state of California, and we went to the world. How then we didn't win world, but we won the state of California. So the same thing, they have competitions, they have the field like the picture below. So, and the robot has to do every year, they have a mission, they have to do something. For example, for this year, that particular year, the robot had to collect all these balls and throw it into this right basket. I could call it a basket. So the blue box there. And then for grade 8 to 12, just to give you a vision, this is about VEX VRC. So they can build this kind of robot, and it's metal. It's for older age. It's hopefully in the Boys Scout. You can use it if you want. And again, the same thing, they supposed to have mission. And this is Ftc Robot. It's very similar to VEX VRC Robot, but the material, this is made of steel, and the pieces that you see, and Ftc mainly made of aluminum. So it's almost the same, but the different materials, different programming, but it's good for, again, high school students. All right, so we are about the time. So let's give you a little bit of time for questions or anything that you want to share with others and with me. Any questions, anything? I see one student with Miss Fatima there. What's the name? What's your name, sir?
My name is Zakaria.
Awesome, Zakaria. Awesome. So, are you in which pack are you in? What's your
I'm
pack?
pack 399. I'm in the bear.
399. Awesome. Oh, bear. Awesome. Awesome. All right. Do you like scouting?
Yeah.
How about robotic?
Yeah, I love that. I love that.
So let's go to this picture. So if you want to build a bridge like this with paper, what do you think? Do you think that you can build it?
Yeah.
And so how about this one? How about this one? Do you like to work with a computer, you know, to...
Yeah.
Have you worked with this or not?
One time in the library, they opened a 3D printer, and so I made a bat thingy. Batman.
Image of a Batman.
Yeah.
Awesome. Awesome. Great job. Great job. Great job. So he is actually a good example for this then. Awesome. 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 So any questions, anything?
I have a question. For the NOVA program, how much time do you typically allocate for that program? Is it like once a week the kids get together for an hour or so, and how long would that last for typically?
For the NOVA, it depends on their grade, their, you know, if they're V below or, you know, bear or wolf, and the project that you get. But typically, for example, for one area like option, for example, B or A, option B is a little bit more complicated, but either way, I think maybe max 2 months, 1 hour per week, you can wrap up everything. However, you need logistics behind it, of course, you know. But I mean, assuming that kids sit there and they're not working the whole 1 hour, assuming that they work, let's say, 30 minutes. So 2 months, I guess, you can wrap up one project. Or
You
1
have
month.
to, and you would also need is it a counselor or a champion for the NOVA program? Would they have require special training or?
If you want to be a trainer, basically, or mentor here, that I put it here, so you need to go to, it's short training, honest with you, training online. It's very short, you know, like other trainings that all of us we had. So you can get that one. It's really is nothing. If you have experience generally in working with computer, generally, let's say engineering, science, technology in STEM. So it's just teaching you general things, but yeah, you can manage it in your pack. It's not really you can be the mentor. Yes, you can get your mentorship here from them officially.
Great, thank you.
So I
Go ahead.
Sorry, how many counselor and mentor do you need per pack?
So technically, from this award for pack, I believe one is enough, because pack is it's unless you want to run different, you know, um, um, basically groups, and if depends on your workload, by the way. But technically, one is enough. You know, just they need one counselor and a mentor to just help them build it. But if you have them, that's enough. Yeah, you don't need to have multiple. But it depends again your workload. By the way, if you don't have time, so maybe two of your packs, two adult leaders of your pack can go and get training.
Sorry, I guess I'm still a little bit confused between the counselor and the mentor. Is the counselor just more of like an administrative person, and then the mentor is the actual technical person that will be guiding?
Exactly. Exactly. Mentor, as you see here, the second on the screen, it says must be subject matter expert. But counselor is as it's mainly is administrator, and so maybe one counselor, one. So you may have different mentors, for example, science, technology, engineering. However, again, my experience tells me that with dealing with BSA, they don't really, at the level of elementary school, any degree or any expertise that you have, typically, if you are generally in science engineering area, so you can cover this. Even if you don't have any degree, you think that you can do it. Typically, no one would tell you that you shouldn't do it. You know, this is the fact. But they should recognize you as an expert, as mentor in one area. Yeah.
As far as like when you're teaching the program, does the council supply any type of teaching material? Kind of like, you know how den leaders have these adventure guides that we use to run our den meetings, right?
Yeah,
Is
exactly.
there a
Yes.
similar type of material available for the mentors as well?
Yes, there is a guideline. If you see here, for each award, basically we have guideline for mentor. For counselor, it's a general thing, but for mentor, you have to see which area do you want to pursue. For example, if I go to see here, I had it actually here. So first of all, for each area, science, technology, engineering, math, there is a guideline and a book for that, basically. And then for inside that area, for example, if I want to give you an example in engineering, again, you have these three areas, and each area has its own guideline. So the mentor should know which area, for example, if he wants to follow the Baloo, the builder, or motorway, or which one does he want or she want to follow. That's important.
Well, will you, in this case, let's say you have a wolf group, a bear group, and a weebo group, do you need separate mentors for each of the um,
Can you speak a little bit louder? A little bit
oh,
hard to.
sorry.
Yeah.
For the wolf, bear, and weebo, in this case, will
Mm-hmm.
you need a separate mentor for each of the group of kids, or that same mentor would be running all of them?
No, that's the same mentor. You can't do it. You know, it's not really a complicated job. No.
Okay.
It, again, depends on your time. By the way, it's
Yeah.
personal. If personally you have time to cover it, you know, from this view of, you know, to talk about an expert person, obviously you can, you know, you can cover everything. Yeah.
All right, thank you.
Unless the adult leaders want to compete with each other, by the way. Just kidding, but so to say that, okay, this adult leader wants to have this bears the wolf, you know, they compete. You know, I'm kidding, but
Thank you.
thank you so much.
So I just had another question.
Yes.
I was talking to um Donna Wolf, and she was, I think, in charge of the STEM Scouts project or something. So I'm assuming that this NOVA thing and the STEM Scouts is a different program totally? Because from my understanding, the STEM Scouts, I mean, it was an entirely different program from this BSS Scouting, like Cub Scouting program. And the kids had to register separately and the pack had to register like separately. But from your presentation here, the STEM Nova is kind of integrated in the Cub Scouts or something? I mean,
STEM Nova is the part of Cub Scout, but it's Nova is an award. It's not the program to teach. On the other hand, it's the outcome of that STEM program. So you can go with that program, but if they want to compete and get awards, then Nova is the basically the platform for that. The reason that why I came up with Nova, I just explained it because it's the, I don't want to say the best, but it's one of the best resources for engineering activities, standard engineering activities for you if you want to run it in the pack. No matter if you want to apply for an award or not. But that one that you're talking about is it's the part of STEM activity. Generally, they will teach to talk about, you know, to work with the projects, STEM projects, but there is no award there, or there is no competition there. Yes, John.
For your spaghetti and paper bridge stuff, where do you suggest getting the weights from?
First of all, if you go with the sand, it's Sea Beach or Home Depot.
Yeah. Okay.
So, but I'm not suggesting Sea Beach because legally you shouldn't harm environment. So Home Depot is the best thing to get actually the weights. I'm not suggesting actually to get the actual weights because, you know, those weights, sometimes you will get a struggle with using them. So the best way is find sand, Home Depot, $5 per bag.
So for, yeah, like the play sand or something like that. So it's a
Play
specific
sand,
grain
exactly.
size. But I mean, like for hanging it from a bridge or something like that, I mean, is that just like hanging it with a bucket or something? And then when it finally collapses, you say, okay, well, here's, you know, the weight of the bucket.
Yeah, exactly. You can measure the weight of bucket actually in advance, and then, yeah, that's the way it works. Yeah.
Cool.
Yeah. Because for the first time when I ran it, actually, I didn't have experience. I started I was at university for the university level students. So they built a big actually structure, and I put all loads that I had in the lab, and I said, oh, I didn't break. So, so I tried to find something to break it, bottom line. But after that, I noticed that the best thing is sand because you can add it incrementally at whatever you want to, and will give you the best answer. Yeah. All right. Any other question? Anything? Okay. So once again, thank you so much for coming to this session, and I hope you enjoyed it. I don't know how can I share this with you. I to ask. They said that we can. I should have your emails. So by the way, I'll check with them to ask them to send the presentation to you and share it with you all. All right.
Is there a way we could get your email address?
Oh, sure. Yeah, it's my email address is. Give me a second. It's here. Sorry. Oh no, sorry. That's give me a second. Share screen here and share it here. So my email is at the end of this presentation. So I just want to have it know it's a free put iCloud. I guess I put that email for you. And I will be happy to be in contact with all of you if you need my help. Here, my last name, Ghafouripur, GHAFOORIPOUR at iCloud.com. Actually, it's my personal email. And my phone number is there. So you're welcome to call me. All right. I guess I have to close it. I guess someone else wants to use this link. I don't know. So, All right. So enjoy your other classes if you have, and if you don't have it, enjoy your weekend, by the way. Have a good day. Thank you. Bye-bye.
Thank you so much.
Thank you.